Another electrical procedure is actually finding short circuits. And the first step in actually finding any short circuit is to actually probe for your actual the condition of the fuse. If you have any short circuit, more than likely you would have popped the fuse. Probe on one side of the actual fuse. You will see, of course, if the fuse is popped, you're not going to see any, the test light is not going to light up. Then probe on the other side to make sure that you do have a supply voltage, because your problem may not be at the actual at the module or circuit itself. But this you would actually this would serve as a dual purpose. One, to test your test light, make sure that it works, and the other to actually test for supply voltage. This actually may sound a little bit simplistic and even dumb, but many a times a technician actually forgets to check on the other side of the fuse, simply finds a popped fuse and immediately starts to hunt down for a short. Remember that you actually need a supply voltage on the other side of the fuse, and your problem may lie somewhere else. For the fuse to pop, you will more than likely have an actual short on the actual circuit side of the fuse, but it is always a good idea to check your actual supply voltage going into the actual circuit itself. In our next example of a short circuit, we see how the actual ground line, it's actually touching the actual ignition side of the ignition feed to the ECM, and this will cause that first it will cause the fuse to pop, but even though even if it doesn't pop, you will still have a shorted voltage supply source, and by simply performing a voltage reading across, in this case, pins number 14 and ground and chassis ground, you are supposed to have 12 volts, since this is the switch side going into the module. A 0 volt condition will actually, of course, indicate that you have a problem. In this particular case, the fuse is down, is popped, and you're not going to see any actual voltage. Again, by doing a voltage drop between pins number 14 and actual voltage source, you will actually immediately see that you are having 12.6 volts across pins number 14 and voltage supply. It's not a good sign, and it actually indicates a problem. It actually indicates an open circuit. Even though you have a short, remember that the actual fuse that has popped is going to be an open circuit between the actual voltage supply and the voltage supply input at pin number 14 of the ECM. Since you are supposed to have a battery voltage or voltage supply with the ignition key closed, a voltage drop between voltage supply or battery positive and pins number 14 should indicate 0 volts or very little voltage dropped across this circuit, since it's supposed to be a through conductor. By seeing, watching that we actually have 12.6 volts or battery voltage, we know that indeed we do have an open circuit, which we know is the actual open fuse. If we were to replace this fuse with a good fuse, of course, more than likely it will blow again. But however, you would, if the circuit was working properly, you will see a voltage very close to 0 volts. A widely used trick on the field in situations like this is to actually not replace the fuse, simply replace it with a headlight rigged